Okay, so now when we have reviewed the different layers of modern web applications infrastructure and the ways they can possibly be attacked, let's put that knowledge in some kind of order, right? So fortunately for us, there is this global effort to standardize approaches to increasing web applications security, and it's called Open Web Application Security Project, and it unites hundreds and thousands of application security professionals that are tasked with collecting that knowledge, putting it into some kind of domains, right, and issuing standards and guidelines on how to reduce security vulnerabilities in the software code. Okay, so for ethical hackers and penetration testers, I would like to emphasize at least two artifacts of those project domains, right? So there are different project domains in OWASP. They have separate groups on mobile applications, separate groups on web services, on web applications, and some of them are just creating those charts of popular vulnerabilities. Okay, so everyone is tasked with some really important job, and you most probably will find value in all the deliverables of OWASP. However, two of them are of the most importance for our cause, I guess. So first of all, there is this web application security testing guide. OWASP testing guide is at version 4 right now, and it's updated quite frequently. What it is, it's basically a guideline. It's not a standard, but it's a document you can use to walk through quite efficient set of exercises that are structured in different domains, yeah, based on different threats that are surrounding the web applications. And going from thread to thread, you can perform different actions. Sometimes there are concrete examples of what you have to do in order to check those vulnerabilities, yeah, that are associated with those specific threats, and in the end have enough data to make quite high quality conclusions about the security level of software. Okay, so that's really large document, I would say. It's intended mostly for dynamic security assessments, of course. There are others that are pertaining to white box testing, like reviewing the source code manually. But for penetration testers, of course, this dynamic approach is more convenient and helpful. Okay, so yeah, OWASP testing guide is your friend. There are different tools that are surrounding that project, yeah, that specific guide. For example, there is an Excel spreadsheet, an actual checklist you can use in order to go through all the exercises and collect evidence of your activities and of vulnerabilities present or not present in the web application. Okay, so that's quite handy as well. And the second one, of course, is OWASP Top 10, right? So that's basically the top 10 project that is aimed at measuring the, I don't know whether that word is applicable here. They're measuring the popularity of different types of vulnerabilities, not certain vulnerabilities, but classes of vulnerabilities that that are out there in the wild. Okay, so of course it's quite subjective, right? So this judgment is made by the community. However, when I look at this chart, I'm pretty much okay with that. So I agree that there is some logical proportion between the frequency of those vulnerability classes. I wouldn't maybe put them in this exact order, but again, everyone has their subjective experiences, and based on my experience, I would probably put XSS at the top. So if that's the frequency, that's more or less realistic. However, this prioritization can be changed. Again, I cannot emphasize that too much. Yeah, so those classes are put in this order not because some of them are more harmful. Okay, that's not the intent, I guess, of OWASP top 10 project. They are there because they are harmful and frequent at the same time. Okay, so injections are happening much more frequently than I don't know, cross-site request forgery causing real trouble. Okay, so that's down in the list not because it's less harmful. It can be based on the web application specifics. It really can cause a lot of trouble, more than an SQLite in the same application. But this is rather a combination of frequency and the level of impact. So that's like risk-based prioritization, more complex than just probability of occurrence or possible consequences. Okay, so let's go through them one by one, and I will give you some idea of what each of them may look like. So first of all, there are injections. Injections are nasty and result from mainly a lack of proper user input validation. Okay, so if there is a way to smuggle your data through user input filtering somehow, and then combine it with SQL statements or CMD comments run by the web application for some reason, or LDAP searches or XPath searches or template creation and execution, that may result in really harmful consequences. For example, if you are able to modify SQL statements that are thrown to the backend, at the server side of the web application, that may cause not only disclosure of sensitive data in the backend, that can, through different specifics of the database management system used by the web application, it may lead to complete compromise of the backend or the web application server. Okay, so that's not rare, I would say. The CMD injection or operating system command injection, of course, is even more risky, because if you can run a command even in a limited user environment, but deliberately formed commands can be run and controlled by you. This of course will lead to some level of compromise, some level of remote access to the server operating system. LDAP, I would say it's limited to data disclosure and maybe data tampering and modification. XPath, okay, maybe two. So if external functions in XPath are not allowed to be queried by XPath search queries, right? It's most probably will result in data disclosure, and that's all.